Hello everyone. In this video, we are going to discuss error handling and exceptions. And the contents that we cover are types of errors and handling exceptions. Types of errors, syntax errors and runtime errors and logical errors. We are going to discuss one by one. So syntax errors or erroneous usage of language syntax. For instance, not indenting the code directly or misspelling a variable or function name. Here is an example that I have a syntax error that I have commented here. We haven't end with the colon here, the function definition. And then we have B here, which is not defined. So let's run and see what will happen. So we get the same error that I have commented here. So syntax error generally easiest to fix due to their nature, and they reside directly in the code as it is written. So a developer does not need to follow the execution of the program to find these kind of errors. So the runtime errors, an exception during the runtime which is not handled correctly. For example, user inputs causing division by 0, or more memory cannot be allocated by the underlying operating system. So here is an example. Let's run and what will happen. So enter a value. I can give 2 and 2. So there is no error, which is so good. And then now I enter 2 again, but I divide the value by 0. So now I get division by 0 error, right? And this is what it is. So this type of errors is often results erroneous usage of the program and not the programmer, because we entered the 0 value. So it's more like erroneous usage of the program. So however, the guard should be put up against these type of errors when it's possible. So logical errors. So if a code is written syntactically correct and executes as it is written, but fails what we expected to do, then it is most likely to be a logical error. So they're hardest to find and fix, but they're not always loud, but it can indirectly cause the code to raise loud errors and also later errors at the later state of execution. So here I have an example. Let's try and run what will happen. So I give 2 and I give 2. So the average of two numbers you have entered is 3.0. Did you find the error here? Which is not the average of 2 plus 2, which is 4 by 2 should be 2, right? But here we get 3.0. So this is the logical error here because we got the wrong output. It's because the order of operations here. So the division was done before the addition. So let's just add the parenthesis and run what will happen again. So I give the 2. So now we get the right answer. So these are the types of errors, logical errors. So now we are going to discuss about exceptions. So when an error is detected during the execution, an exception is raised. And more exceptions encountered so far has probably not been handled, but instead produced some error output, as we have seen in before, 0 division error, right? And then we have this type of error is one of the many errors, one of the many errors in Python. So there are many built-in exceptions. So code can behave weird, give erroneous results as we did, or even freeze for multiple reasons. And some of examples, erroneous input from the user and failed HTTP connection and operating system unable to allocate memory, are also misspelled data input. All of these errors may end up in a runtime error that can be prevented if due care is taken. Let's see how. So rising exceptions. When writing code, which is to be used by others. Raising exception can be a powerful and simple way to inform the user of erroneous usage. This is the syntax for that. And here is an example. I use raise exception. So we input the value, and if the value is greater than 5, then we want to raise an exception. A should not be more than 5, and the value was given whatever we give the value. Let's try and what will happen. So here I give 2, there is no error. And what if I give 6? So now I get an raise exception, what we have written here. So because we gave the 6, which is our condition, is the fail, right? So, and yeah, here in this example, we got clues about what to see what went wrong. So it helps to debug our code. And asset statements is a debugging aid which tests a condition, and it can be used for internal self checks for a program. Here is an example. I input the value and I have this condition here. If the value is between these, then there should be no exception, nothing. It will the program run as it is. But if the value is outside this range, then we get an error, which is assertion error. So let's run and see. So if I give 3, then there is no problem. But if I give the value 101, then it freezes. Sometimes takes little time. So if we entered 101, then we get an assertion error, and also a clue that for helping debugging, A must be between 0 and 100, but was given 101. So in this example, if the condition is true, it does nothing and continues execute, sorry. Otherwise, it tries an assertion error here with an optional message that we give. So after the assertion error thrown, the program will halt and it will not continue. But what if what we don't want? So let's see how we can handle those type of exceptions. So an exception can be caught and handled by Python program. For this, a try and except block is used to catch the exceptions. So Python executes code following the try statement as normal part of the program, and the except statement as a program responsive to any exception from the try clause. So here is an example. I have input A, B values, and then I say try A by B, and then if an exception occurs, then say the number cannot be divided by 0. So let's see. 2, 2. It's correct. So there is no exception. And let's run again. 2, 0. So here, now we didn't get an error message. Instead, our program executed, and then we get what we have written there in except. So in this example, as you have seen, we do not have any information about the type of error that was thrown. So we need to catch the error that was thrown to see what went wrong. So we can here we can do that by using these like this. So for the same example I just added, in this program we can accept 0 division error as error and then the print error. Let's run the same example. Here I didn't write anything, instead I print the error whatever it is. So here 2, in this case 0 division error. So 2, and then when I give 0, then here it gives the error division by 0. Another example, let's look at another exception. So I have a file, which is example file.txt as a file, and then we read the file. And if it's not found, that's the file not found an error, we can accept, yeah, as accept, not accept, sorry, as an error. So let's see what will happen here. I run this code and then it says no such file or directory in example file dot the file that gives the name example file.txt text file, because I don't have that file in my system. So we also may anticipate multiple exception from our program. Hence, we can include multiple exception handlers to differentiate them. For example, here I have added one more exception compared to before. So here I input values, and then I have a try, which is the division A by B, the input values that we have. And then I have added also one more thing to input C value and then print C here. So with my try here, I can expect two types of exceptions. One is zero division error. If I do it, this one with the divide by zero, B, if the B is divided, if the B is zero, or we can also expect value error, because here I said like input the value, which is int, but what if I give other than int any other data type value? Then I can say that we can also accept that as value error as well. So let's run and see what will happen. So I say, so 3, 0. The division was not success because of the error. So this exception was thrown, right? So let's run again. And now we can say 2. Oh, sorry, I have to run it again. So 2, 2, which is there is no exception because it's dividable. And then now I say another one here on the C, enter the value for the C. So here I give instead of integer, I say P. So what did it say? Invalid input was given, because now we get an exception which is thrown by this one. So if we expect more than if we accept other exceptions that we don't know what they are, we can just also use this one. For example, let's say I don't specifically say value error, but instead I just say accept exception as error and print error, and let's run. So I just say which is correct, and now when I enter P, so it catches also invalid literal. So the same error that we had it as when we have this one, right? But now we have commented. So we can also use this one if we expect something else, some other exception from our program. So as you have seen, a try class is executed until the first exception is encountered, right? So we can either one of them, then it stopped. And then in except clause, we determine how our program should respond to an exception. So in the absence of exceptions, we can use else clause to tell the program to execute a certain block of code. So here is an example with else. So I have this same example as before, but now I have added else here. Let's run here. And 2, 2. Then else class was executed, right? And what if we give something else, which is divided by 0, the number divided by 0? Then let's see, the division was not success because of the division by 0. So we did not run this else clause, right? So we only run else clause if there is no exception in the program. So and one more thing, we can also have try and except clause in else clause if our program task requires. So here, I mean, you can write try and except as well. Depends on our program task. So I mean programming task, whatever the task that we are working on. So one more thing that we can use finally clause as well to say something to clean up after the execution of our code. For example, closing a file. No matter whether we have an exception or not, finally clause will always be executed. So here is an example. The same example, I just added the finally one. So let's run here. 2, 0. So we have got an exception, which is this one, right? 0 division error. So, but even if we have an exception, still we have executed this one, ending the execution here. We get it. So no matter if we have an exception or not in the program, the finally class always be executed. So I hope I hope you get an understanding of using rise class and assert and try class, except class, else class, and finally class. So in Python, as you have seen now so far, there are many built-in exceptions. That one, for example, we have used zero division error, value error, and file not found error. And also we can create self-defined exceptions as well. Here is a reference, python.org. And here I have opened the site already here. So we have exception hierarchy, and they have listed all the exceptions that we can use here, built-in exception or exceptions here. So we usually we use this one. So it depends on your programming task. You could find the one that is suitable for your task, and you could get some help from this python.org. Yes, that's what for today's lecture. Thank you very much.